Whoa! Look! What's that in the sky? A star suddenly flares up, shining incredibly bright. It's brighter than a full moon. It's a supernova, a massive star exploding at the end of its life. Imagine the biggest fireworks show ever, but a million times bigger and happening trillions of miles away. Could a supernova happen near our sun? What would happen to our planet? Would it be dangerous? Let's find out. When you gaze up at the night sky, the stars might seem eternal. Tiny, sparkling points of light that have always been there and always will be. But in reality, stars are living, dynamic objects, each with its own unique life story. They are born, they live, and eventually they die. And sometimes, their deaths are among the most spectacular events in the universe. Stars are essentially gigantic, blazing spheres of gas, mostly hydrogen and helium, held together by their own gravity. Deep within their cores, temperatures and pressures soar to unimaginable levels, creating the perfect environment for nuclear fusion. This process fuses lighter elements into heavier ones, releasing an enormous amount of energy in the form of light and heat. The energy produced by nuclear fusion pushes outward, counteracting the force of gravity that's always trying to pull the star inward. For millions or even billions of years, this delicate balance keeps the star stable, shining brightly in the sky. It's a cosmic tug-of-war, with gravity and fusion locked in a constant struggle, but nothing lasts forever. Over time, the star uses up its nuclear fuel. As the fuel runs low, the fusion reactions slow down, and the outward pressure begins to weaken. The star starts to change, swelling up or shrinking down, depending on its size and mass. For some stars, this is a gentle process. But for the most massive stars, it's the beginning of something truly dramatic. When a star much bigger than our sun reaches the end of its life, it faces a crisis. With its fuel nearly gone, it can no longer generate enough energy to support itself against gravity. The core contracts, becoming denser and hotter, while the outer layers may expand and become unstable. The star teeters on the edge of collapse. Suddenly, gravity takes over completely. The core collapses in a matter of seconds, squeezing the star's material into an incredibly small space. This collapse is so intense that it triggers a powerful shockwave racing outward through the star. The shockwave blasts through the star's outer layers, releasing an unimaginable amount of energy. In just a moment, the star's core collapse is transformed into a titanic explosion. The energy released in this instant can outshine an entire galaxy, making the star visible across vast distances in space. This is a supernova, a cosmic explosion so powerful that it can briefly light up the universe. Supernovae are not just spectacular to watch, they also play a crucial role in the cosmos. They scatter elements like carbon, oxygen, and iron into space, seeding future generations of stars and planets. In a way, every atom in your body was once part of a star that ended its life in a supernova. So, the next time you look up at the night sky, remember, the story of a supernova is the story of cosmic creation and destruction, written in the stars themselves. Supernovae are among the most powerful and awe-inspiring events in the universe, marking the dramatic end of a star's life. But did you know that not all supernovae are the same? In fact, astronomers have identified two main types of supernova, each with its own unique story and cosmic consequences. Let's explore how these spectacular explosions come to be and what makes each type so fascinating. The first type, known as Type Ia supernovae, occurs in a very special kind of system, a binary star system. Here, two stars are locked in a gravitational dance, orbiting around a common center. These pairs can be found throughout our galaxy, and sometimes one of the stars in the pair is a white dwarf, the dense, hot core left behind after a star like our sun has exhausted its fuel. In these binary systems, the white dwarf can begin to pull material, mainly hydrogen and helium, from its companion star. This process is called accretion, and it's a slow but relentless siphoning of stellar matter. Over thousands or even millions of years, the white dwarf grows heavier as it accumulates more and more material from its neighbor. Eventually, the white dwarf reaches a critical mass, about 1.4 times the mass of our sun, a limit known as the Chandrasekhar limit. At this point, the pressure and temperature inside the white dwarf becomes so extreme that a runaway nuclear reaction ignites. In a fraction of a second, the star is torn apart in a brilliant explosion, releasing an enormous amount of energy and outshining entire galaxies for a brief moment. This is a type Ia supernova, and it leaves behind no core, just a rapidly expanding cloud of gas and dust. The second main type, called Type II supernova, happens in a very different way. These explosions occur in massive stars, much larger than our Sun, that live fast and die young. Unlike the binary systems of Type Ia, these stars are alone, burning through their nuclear fuel at a furious rate. As these massive stars near the end of their lives, they run out of fuel in their cores. Without the outward pressure from nuclear fusion to support them, gravity takes over. The core of the star collapses in on itself in a matter of seconds, becoming incredibly dense and hot. This sudden collapse sends shock waves racing outward through the star's outer layers. The result is a spectacular explosion, a Type II supernova. The outer layers of the star are blasted into space, creating a brilliant display of light and energy. What's left behind can be a dense neutron star, or if the original star was massive enough, a black hole. These explosions are not just beautiful. They also play a crucial role in spreading heavy elements like gold, iron, and oxygen throughout the universe, seeding future generations of stars and planets. Supernovae in all their forms are the engines of cosmic change. A supernova explosion is an amazing sight. For a short time, the supernova can outshine an entire galaxy. But there's a lot more going on than just a bright light. The explosion blasts out material from the star in all directions, creating a beautiful cloud of gas and dust called a supernova remnant. These remnants can be seen for thousands of years after the explosion. They're like giant cosmic fireworks displays. Supernova explosions are powerful events. They release enormous amounts of energy as light, heat, and radiation. They also create shock waves that travel outward at incredible speeds. These shock waves can trigger the formation of new stars. They can also disrupt the orbits of planets around nearby stars. The radiation from a supernova can be dangerous to life on planets too close to the explosion. A supernova explosion is a spectacular event, but you wouldn't want to be too close to one. How close is too close? Well, that actually depends on the size of the star and the type of supernova. Astronomers believe that a supernova within about 30 light-years of Earth could be dangerous. Luckily, there are no stars that close to us that are about to go supernova. Let's imagine a supernova did happen close to Earth. What would happen to our planet? The answer really depends on how close the supernova is. If the supernova were close enough, the intense radiation could strip away our ozone layer. The ozone layer protects us from harmful ultraviolet radiation from the sun. Without it, life on Earth would be in big trouble. A nearby supernova could also change Earth's climate. The radiation could cause chemical reactions in the atmosphere, leading to global warming or cooling. These changes could be dramatic and happen quickly, making it difficult for life to adapt. While a very close supernova could be devastating to life on Earth, it's important to remember that these events are very rare. And scientists are constantly searching the skies, looking for any stars that might pose a threat to our planet. Astronomers are like cosmic detectives, venturing into the darkness of night to unlock the mysteries of the universe. With their eyes fixed on the heavens, they dedicate countless hours to observing the stars, planets, and galaxies that fill our sky. Their work is a blend of curiosity, patience, and scientific rigor, as they seek to answer some of humanity's oldest questions. What lies beyond our world? How do stars live and die? Are we alone in the vastness of space? Using powerful telescopes both on the ground and in space, these scientists peer deep into the cosmos, gathering light that has traveled for millions, sometimes billions of years to reach us. Every night they adjust their instruments with precision, scanning the sky for new phenomena and subtle changes. They study star charts, analyze data, and compare their findings with historical records, always searching for patterns and clues that might reveal the secrets of the universe. Through their careful observations, astronomers can determine which stars are nearing the end of their lives, such as red giants that are about to explode in spectacular supernovae. By analyzing the light from these stars, they can tell what elements they contain, how old they are, and what will happen to them next. This knowledge helps us understand the life cycle of stars and the dynamic processes that shape our galaxy. Not only can astronomers identify dying stars, but they can also map out which ones are far away and pose no threat to our solar system. By measuring the distance and brightness of these stars, they can create detailed maps of the night sky, highlighting constellations and distant galaxies. This mapping allows us to appreciate the vastness of space and our tiny place within it, while also reassuring us that most cosmic events are happening far, far away. The idea of a supernova, a massive star exploding in a brilliant burst of energy, might sound frightening. After all, these explosions release enormous amounts of radiation and can outshine entire galaxies for a short time. But thanks to the diligent work of astronomers, we know that the stars capable of going supernova near Earth are extremely rare, and none are close enough to pose a real danger to our planet. So, while the universe is full of dramatic and sometimes violent events, there's no need to worry. Stargazing can remain a peaceful and awe-inspiring activity, as the chances of a supernova occurring close enough to harm Earth are incredibly small. Most of the stars we see twinkling above us are stable and will continue to shine for millions of years to come. The odds of a supernova happening close enough to impact our world are so tiny that it's not something we need to lose sleep over. Our planet is protected by vast distances, and the universe is much larger and more complex than we can imagine. The night sky, with all its wonders, remains a safe and beautiful place to explore with our eyes and our imaginations. Thanks to the tireless efforts of astronomers and scientists around the world, we can all sleep soundly, knowing that the cosmos is being carefully watched. These dedicated individuals are always on the lookout for new discoveries, keeping us informed and safe as we continue our journey through the universe. So, next time you gaze up at the stars, remember, the watchers in the night are always there, keeping a vigilant eye on